Alright, in this video I'll be solving the 9709 February March 2025 Pure 1 paper. For copyright reasons, I will not be able to display the paper, so make sure you have the paper with you as we work through the questions. And before we get into the video, I know this probably doesn't mean much to you, but to me it means a lot. I just want to kindly ask that you check that you've subscribed to the channel if you find the videos that we make here useful, because it goes a long way, even if it feels like it's just one small click of a button. So I'd really appreciate if you subscribe to the channel. Thank you. Let's dive right in. Number 1. A curve has equation y is equal to 5 plus 3x minus 2x squared, and a straight line has equation y is equal to kx plus 13, where k is a constant. Find the set of values of k for which the curve and the line do not meet. Okay. So the key phrase there is do not meet. So this here should give it away that this is a discriminant question. And we know that if we've got a situation where our line, I'll just use the x-axis as our line, and our curve, if these two do not meet, then we know that b squared minus 4ac, our discriminant, is less than 0. So this is the first thing you should get from this question, where they tell you that your curve and line do not meet. Your discriminant has to be less than 0 since we have no real roots. So you start off by equating your curve and your line together and then reduce this to a 3-term quadratic. Once you're there, you can identify A, B, and C and then just substitute into the discriminant. So let's do that. We've got our curve 5 plus 3x minus 2x squared is equal to kx plus 13. And I'll move everything to the right hand side because I want the coefficient on x squared to be positive. So we end up with 2x squared plus kx minus the 3x plus the 13 minus the 5, and this is all equal to 0. So what we have is 2x squared plus, I'm going to factor out the x here. So that becomes k minus 3 inside the brackets. Then we've got 13 minus 5, which is 8. And this is all equal to 0. So now we've reduced it to a 3-term quadratic. We can clearly read out what a, b, and c are. Because remember, a quadratic is anything that can be expressed in this form, a squared plus bx plus c. And this is equal to 0. So we can figure out what a is, what b is, and what c is. Our a is going to be 2. Our b is going to be this whole bracket. And then our c is the constant. And so now we can just substitute into b squared minus 4ac is less than 0. So that becomes k minus 3 squared minus 4 times a, which is 2, times c, which is 8. And this is all less than 0. We've got a quadratic here. Let's expand it. So square the k. Then 2 times k times minus 3. That's minus 6k. Then square the minus 3. You get a positive 9. Then minus 4 times 2. That's minus 8 times 8 minus 64. And this is all less than 0. And if we simplify here, that's k squared minus 6k plus 9 minus 64, that's minus 54, 55 is less than 0. Okay. So now notice that we've got a quadratic inequality. So we have to solve this quadratic inequality. The steps for solving a quadratic inequality are as follows. First, solve the quadratic equation. Get your roots or the solutions to your quadratic equation. Then determine which regions you want. And then proceed. And then you get your set of values. So in this case, we're going to say k squared minus 6k minus 55 is equal to 0 because we want to solve the quadratic equation first. And can we factorize this by side? I think we can. We want vectors of negative 55 that add up to negative 6. So I know 11 times 5 is 55. So I want negative 11 plus 5 because that gives me negative 6. Okay. So that means either k is minus 5 or k is 11. So those are the solutions to the quadratic equation. Now to determine the solutions to, and so we've got our curve, I should probably use k here. Since this curve is of the form y is equal to k squared minus 6k minus 55, our values for k are minus 5 and 11. So the inequality is asking where is this curve less than 0, or in other words, where is this curve below 0 or below the x-axis or below the k-axis. That's this portion here. That's when our curve is below 0. So we can therefore say for our curve to be below 0, k has to be between negative 5 and 11, and that will be our final answer. Let's move on to question number 2. The diagram shows the curve with the equation y is equal to 2x squared minus 5x plus 3. The curve crosses the x-axis at the point P10 and M is a minimum point. So we are told in part A, we're told to find the gradient of the curve at the point P. Okay. So here what they are asking for is the gradient of the tangent to the curve. If I can write tangent. So the gradient of the tangent to the curve at the point P. That's what they want. So the first step to get the gradient of the curve is we first have to take our equation y equals 2x squared minus, it's 5 over x, but I'll write this as 5x to the negative 1 plus 3. And we need to get the gradient function dy dx. So if you differentiate 2x squared, you get a 4x. And then here you've got negative 5. Bring down the power, that's negative 1. X, subtract 1 from the power, that's negative 2. If you differentiate a constant, you get 0. So dy dx here is equal to, that's 4x plus 5 over x squared. You can keep it as x to the negative 2, or you can write it as over x squared. So this is our gradient function. And this is the function that gives us the gradient of the curve at any specific point. So if I wanted the gradient of the curve at that point there, I just need to know what the x value is and substitute the x value in there, and I get the gradient. If I want the gradient to the curve at this point here, I need to know what the x value is and then just substitute into the gradient function dy dx. In this case, we want to know what the gradient is at this point here. So we know that at this point P, our coordinates are 1, 0, as given by the question. So we can just substitute x with 1 in our gradient function and we should get our gradient. dy dx is equal to 4 times 1 plus 5 over 1 squared, which is just 4 plus 1. 4 plus 5, which is 9. So gradient is 9. That's our final answer for part A. Part B says find the coordinates of M. So note that M is a minimum point, and so hopefully that should get you thinking of how we're going to approach this question. Anytime you see minimum point, maximum point, stationary point, the first thing I want you to think about is that dy dx is equal to 0. This is going to be the main idea anytime you're dealing with stationary points. So we are going to do that. In part A, we already evaluated what dy dx is, so we don't have to differentiate again. We can just take the result we got from part A, equate that to 0. So 4x plus 5 over x squared is equal to 0. And to get the coordinates of our stationary point, we just need to solve this equation. And we can do that by getting rid of the denominator, so we can multiply through by x squared and get 4x cubed plus 5 is equal to 0. And so you get 4x cubed is equal to minus 5. You get x cubed is equal to minus 5 over 4. And you get that x here we want to get rid of the power 3, so raise it to the power 1 over 3. What you do on one side, you do on the other side. So x is equal to, we can punch this into the calculator, and this is, so they say to give the answer to 3 significant figures. But now I'll just write negative 1.0772. Because I still want to use this value to calculate another value, I need to make sure that whatever value I use as x is to more than 3 significant figures, because I know that the final answer I want is going to be to 3 significant figures. So we need to find what y is. In this case, the equation of the curve is y is equal to 2x squared minus 5x to the negative 1 plus 3. I can just substitute my x value in there and get our y value. So it was 2x squared negative 1.0772, and this is squared minus 5 times negative 1.0772. This is to the power minus 1 plus 3, so you get that y is equal to, this is 2 times negative 1.0772, and this is squared minus 5 times negative 1.0772, and this is to the minus 1 plus 3, and that gives us 9 point, this one I can give to 3 significant figures because that's going to form part of my final answer. So we can say that the coordinates of our minimum point M are our x value, give that to 3 significant figures, so negative 1.077, so 0.8, and then y 9.96 to 3 significant figures, and that's our final answer. Number 3, part A, find the complete expansion of 2x minus 3 over x to the power of 4. Alright, so for this, we're going to use the binomial expansion formula, which you will find in the MF19. So it will be given as a plus b to the n is equal to a to the n plus n choose 1. This notation here, n1, that's the same as n choose 1. So don't be surprised when you see them give it in a sort of vector form. Right, it's the same as the notation that you're used to. N1, and then this is a to the n minus 1, b to the 1 plus n choose 2, a to the n minus 2, b to the 2, and this will continue all the way up to n choose n. Oh, the last term will really just be b to the n. Okay, again, it's in the MF19, so you don't need to memorize that one. So in our case, we have that our a is going to be the 2x. Our b, be careful, each term carries the sign behind it. So b is negative 3 over x. And then our n is the power, n is 4. So we can use that to get our complete expansion. So the first term is going to be a to the power n, so that's 2x to the power 4 plus n choose 1, so 4 choose 1 times our a, which is 2x, and this is to the power 4 minus 1, which is 3, times our b, which is negative 3 over x, and this is to the power 1 plus 4 choose 2 times 2x raised to the power 4 minus 2 times b raised to the power 2 plus 4 choose 3 times 2x to the power 1 times negative 3 over x, and this is to the power 3, and the last term, that's just b to the power n. So that's just negative 3 over x to the power of 4. Okay. And now we need to simplify our coefficients. Be careful here. Notice that it's 2 times x to the power 4. So raise 2 to the power 4 first, and you should get that 16. Then raise the x to the power 4. X to the 4. And 4 choose 1. That's 4 times. Here we'll do the same thing. Raise 2 to the power of 3. That's 8. Raise x to the power of 3. That's x cubed. And this is being multiplied by negative 3 over x. We'll come back and simplify that. 4 choose 2, that's 6. Multiplied by 2 squared, that's 4x squared. So x squared multiplied by negative 3 squared, that's 9 over x squared. So x squared plus 4 choose 3 should be 4, right? Yeah. 4 choose 3 is 4 times 2x times 2x. And then here we've got negative 3 cubed, so negative 27, and then x cubed, and plus negative 3 to the 4. I think that's 81. Yes, that's 81. And this is over x to the 4. All right. Let's simplify further. So we've got 16x to the 4. Here we have, I'll do the numbers first, the integers. 4 times 8 times minus 3. So that's 4 times 8 times minus 3. That gives us minus 96. And now let's look at what's happening to the x's. So I've got x cubed divided by x. Remember our laws of indices? Let's say if you've got a over a to the power of m over a to the n, this is going to be a to the power of m minus n. In our case, we've got x cubed over x, which should be x to the power of 3 minus 1, which is x squared. Okay. So that's going to be x squared plus, and we'll continue to do the same thing. So we've got 6 times 4 times 9. 6 times 4 times 9, that's 216. And then we've got x squared over x squared, so they just cancel out. Okay. Then we go to the next one. Doesn't look like it's positive, so I'll remove that. We've got 4 times 2 times minus 27. 4 times 2 times minus 27. That's negative 216. And then what's happening to the x's? So we've got x over x cubed. So that's x to the power 1 minus 3. And so that's x to the power of minus 2. And then lastly, we've got, in fact, so that I'm consistent, I'll just write this as over x squared, because I can see my last term here is of the form 81 over x to the 4. So this here is the complete expansion of 2x minus 3x to the 4. It's quite tedious, actually. But oh well. We need the marks, so we will do the dirty work. Part B. Hence determine the coefficient of x squared in the expansion of x squared plus 5 times 2x minus 3 over x to the 4. Okay. So x squared plus 5 times 2x minus 3 over x to the 4. And we want the coefficient of x squared here. So the first step, or the first thing that you're going to do, is to replace this bracket with its expansion. Because remember, that was part A. In part A, we found the full expansion of this, which is that there. So we can replace that with the expansion, which is 16x to the 4 minus 96x squared plus 216 minus 216 over x squared plus 81 over x to the 4. Okay. And the question is, if we were to fully expand this, what's going to be the term in x squared? What's going to be the coefficient of the term in x squared? So obviously we don't want to expand the whole thing. It would be long and unnecessary, but if worst comes to worst, you are in the exam and you have no clue what to do, you can fully expand the whole thing and just find the term in x squared and therefore the coefficient. The way that I want you to approach this is to find all the possible combinations that will give you a term in x squared. So if I pick x squared from this bracket, what do I have to multiply it by from the other bracket to get a term in x squared? So obviously it's the term that's independent of x, because if I do x squared multiplied by 216, I get a term in x squared. Okay, so this is going to be the only way for me to get a term in x squared if I take this x squared from this bracket and multiply it by something from the other bracket. The other way I can get x squared is to take this 5 and multiply it by negative 96x squared. Okay, so that would be plus 5 times negative 96x squared. There are going to be no other possible combinations that will result in x squared. So that means these are the only two combinations we need, and we can therefore then simplify those to get our term in x squared. So that's 216x squared, and then we've got 5 times negative 96, which is negative 480x squared. If we simplify that, that's 216 minus 480, so negative 264x squared. So remember, the coefficient is the number multiplied in your variable. So our coefficient is the negative 264. So therefore, coefficient of x squared is negative 264. And that's our final answer. Number 4. The diagram shows a triangle OAB. Okay, so we've got some big triangle. And it goes back up. That's OAB. The diagram shows a triangle OAB where OA equals OB equals 10 centimeters. So this whole thing would be 10 centimeters, and this whole line is 10 centimeters. And angle AOB, which is this angle, is 0.8 radians. Okay. And then points C and D, we're going to have some point C and D on OA and OB respectively are such that arc CD is part of a circle with the center O and radius 6 centimeters. So that would mean this distance from O to C is 6 centimeters, the distance from O to D 6 centimeters. And since we know the whole distance from O to A is 10, that must mean from C to A, that's just 4 centimeters, and that's 4 centimeters as well. Okay. The shaded region is the arc bounded by the arc CD and the line segment CA, ABD, and BD. Okay. So that's our shaded region right there. And the question says, find the perimeter of the shaded region. Okay. So if we want perimeter, let's find what lines and what arcs bound our region that we're interested in. Because remember, perimeter is distance right around your shape. So in this case, our perimeter is going to be the line AC plus the arc CD plus the line BD plus the line AB. That is everything that bounds our shaded region. So we know some of these values. We know that AC is 4. We know that BD is also 4. We don't know arc CD. We don't know AB. We can start with arc CD. We know that the formula for arc length as given by the MF19 is r theta, right? So arc CD is coming from a circle with center O, radius 6, and our angle is 0.8. So arc CD is just 6 times 0.8, which is 0.8 times 6. That's 4.8. That's arc CD. And then to get the line AB, there's a few ways you can do it. The first thing that comes to mind is the cosine rule, because you've got the two sides. If I'm to just redraw this triangle on the side, right, we have OAB. We know this angle is 0.8 radians. We know OA is 10 centimeters, OB is 10 centimeters. So we've got two sides and the angle between them. So we can use the cosine rule to find the length of AB. So we can use the cosine rule, and I believe the cosine rule says a squared is equal to b squared plus c squared minus 2bc cosine of a, right? Yeah. And so in our case, that would mean the line AB squared is equal to b squared c squared minus 2bc, so 2 times 10 times 10 times the cosine of A. Angle A will be the 0.8. So we have that AB squared is equal to, that's 10 squared plus 10 squared minus 2 times 10. And for some reason, I'm also not in radians, I was in gradient. 10 cosine of 0.8. And we get, this is 60.65866, and so on. So AB would be the square root of that, which is 7.7884. This is one way in which we could find AB, but if you're like me, I struggle with remembering or recalling the cosine rule formula correctly. So instead of using the cosine rule, anytime I've got an isosceles triangle, I just split the triangle in half, right? And so if we just take half of that triangle, it means we're cutting our angle there in half to 0.4, this line, that's still OA. And so that's 10 centimeters. And this is a right angle, right? And what we're interested in would be, let me just call that point M. What we're interested in is line AM, because line AM would be half of AB, right? And once we have this triangle, it's a right angle triangle, we can use SOHCAHTOA. So we have that we have the hypotenuse, which is OA, and we are interested in the opposite, which is AM. So that has to be sine. So you can say that sine of our angle 0.4 is equal to our opposite, which is AM, over our hypotenuse, which is 10. So AM is equal to 10 sine of 0.4. And remember, AM is half of AB. So half of AB is 10 sine of 0.4. If you multiply both sides by 2, you should get that AB is 20 sine of 0.4. We punch this into the calculator. That's 20 sine of 0.4. And that gives us AB is 7.7884 as well. So I tend to lean to this idea of cutting the isosceles triangle in half and then using SOHCAHTOA instead of using the cosine rule, because I struggle to remember the cosine rule formula. So do whatever suits you best. All right. So now we have everything we need to find our perimeter, right? Our perimeter, if I can zoom in. Okay, there we go. Our perimeter is equal to 4 plus 4, which is 8, plus arc CD, which is our 4.8, plus AB, which we just evaluated to be 7.7884. So therefore, our perimeter has to be equal to, so that's going to be 8 plus 4.8 plus 7.7884. That's 20 to 3 significant figures, 6, or units are centimeters. That would be our final answer for the perimeter. That was part A of number 4. Part B says find the area of the shaded region, of course. How creative. By the way, I don't know if you've noticed, but most of the time for circular measure, your question is going to be of the format, find the perimeter of this, find the area of that. Or they just change up, is going to be what shape they give you to play around with. But that's just the general format. You've got a perimeter question and a shaded area question. Yeah, anyways, if we go back to our diagram, let me just copy this down there. If we come back to this diagram here, we want the shaded region. So I want you to notice that the shaded region is going to be the big triangle OAB minus the sector OCD. Because if I take the sector out of our red triangle, I remain with the shaded region. So I can say that my area is going to be our big triangle OAB minus our sector OCD. Okay. So to get the area of a triangle, here the formula we want to use is the half AB sine C. So in our case, A is going to be this whole side, which is 10 centimeters. B would be this whole side, which is also 10 centimeters. So half times 10 sine of the angle between those two lines, which is 0.8, 0.8 minus sector OCD. Remember the formula for area of a sector is half r squared theta. So half r, this is sector OCD. Sector OCD has radius 6. So half times 6 squared times theta. The angle in our sector is still 0.8. So 0.8. And so our area has to be, we can just punch that into the calculator, That's 1 over 2 times 10 squared times sine of 0.8 minus 1 over 2 times 6 squared times 0.8. And so this gives us 21.5 centimeters squared because it's area to 3 significant figures. And that will be our final answer. Number 5. An arithmetic progression has the first term 5 and common difference 6. With this progression, find the sum of all the terms that lie between 150 and 400. 6 marks. What a question. Okay. So let's just digress for a little bit so we can actually understand what on earth is going on here. So if I gave you an arithmetic progression of the form, let's say it starts with the term 2, and then it goes on to 4, it goes on to 6. Clearly our common difference, yes, is 2, 8, and 10, and 12, and 14, and it continues to go on. And then I asked you to find the sum of all the terms that lie between 5 and 11, right? Like sum of all terms between 5 and 11. So between 5 and 11, the first term that's more than 5 is your 6. The last term that fits within this interval 5 and 11 would be 10. So what I'd be asking you to do is to find the sum of 6 plus 8 plus 10, which would be 24 in this case. So this is exactly what the question is asking you to do, except now it's with 150 and 400. Obviously, we can't just try to write out the whole progression until we find the first term that's more than 150 and the last term that's less than 400. That would be way too long. So we want to do the same thing, but of course at a bigger scale. So we need to find here, like we did, we need to find the first term that fits within this interval, and we also need to find the last term that fits within this interval. So the way we can do that is to say, I'll call this first term that fits within our interval, I'll say that it's term number P, or the term in position P, and the last term, I'll put it in position Q. So we want the first term that fits within this interval, it has to be at least 150, right? Because maybe let me scale this up so that it actually makes sense. We could have something of the form, so obviously our first term is 5 and 11, and then this would continue to go on until we get to, maybe we could do 1, let's say it's 148, and then the next term, if we add 6, is 154, 160, 166, and then this would continue to go on, let's say to maybe 398, or let's do 392 and then 398, 398, and then after this it's plus 6, 404. So assuming that this is what our sequence looks like, right? It would mean our cutoff point would be here, because this is the first term that's more than 150, and then our cutoff point this side is here, because this is the last term that's more than 150 but less than 400. So we need to find the actual positions of these terms. This is what I've called P, and this is what I've called Q. We need to find what P, position P, actually is. because once we have that, then I'll know the first term that fits within this range they've given us. If I find Q, I'll know the last term that's in this range. And once we have that information, it's very easy to get the sum. So we're saying that the term in this position, it can be equal to 150, right? But as you've seen in my example, it may not be necessarily be equal to 150 because the term previous to that is 148, which is not 150, right? So the first term that's greater or equal to 150 is 154. So that's a possibility. So that's why we're not just saying UP is equal to 150 because it may not necessarily be equal to 150. Okay, and then we'd do the same thing for the last term, which we're calling UQ. This one has to be less than or equal to 400, right? Because here, as we can tell, that's 398. The last term that we will accept is 400. Anything more than 400, we won't accept. So we want to find the last term that's just less than 400 or equal to, if that's the case. So the UP, we're using our nth term formula, which says a plus n minus 1d. UP is going to be a is 5 plus our n, that's p, minus 1, our d, that's 6, and this is greater or equal to 150. Okay, and so this is going to be, we want to make p subject of this inequality. So I'm going to move the 5 to the other side. I've got p minus 1 times 6 is greater or equal to 150 minus 5, that's 145. Divide both sides by 6. P minus 1 is greater or equal to 145 over 6. Add 1 to both sides, so P is greater than or equal to, excuse me, P is greater than or equal to, the maths is killing me, 145 over 6 plus 1, which is 25.1667. Right. I want you to keep in mind that P represents the position, right? The 5 is the term in position 1. The 11 is the term in position 2. The P, or the 154 in this case, is the term in position P. So P is going to be an integer. So we want the integer value of the first term that's greater than 150. So the first term that's greater than 150 is going to be in position 26 because that's the first integer that's greater than or equal to. That's the first integer that's greater than 25. So P has to be 26. And we can double check this. If we are to do U26, that's going to be A plus n minus 1, 26 minus 1, D. So that's 5 plus 25 times 6. That gives us 155. And so now what you actually notice, we're actually pretty close with our guess. What you notice is that the first term here is going to be 155. That's the first term that's over 150. And the previous term, we can get that because we know what D is. Our D is 6, so it must mean the previous term is 149. And clearly 149 is not 149 is not greater than 150, so it's not within the interval that we want. 155, that's position 26. This is position 25. And then if I added there, that would be 161, 167. And we continue. Now we need to figure out what the cutoff point is on this side. The last number that's less than 400. So we get that from saying that we want a term that's less than or equal to 400. So that's going to be same procedure, nth term formula, 5 plus q minus 1 times d, which is 6, less than or equal to 400. Subtract 5 from both sides, q minus 1 times 6 is less than or equal to 395. divide both sides by 6, q minus 1 is less than or equal to 395 divided by 6, add 1 to both sides, 395 over 6 plus 1, q is less than or equal to, so that's 395 over 6 plus 1, which is 66.833. So we want the last term that's less than or equal to 400. So we want the last integer value that's less than or equal to 66.83. So the last integer value, because remember q is a position, so it's an integer, because the number of the term is going to be a whole number. It's going to be an integer. Here, this is just guiding us and telling us that q has to be less than 66.833. But the last integer value that satisfies this condition is 66. So it would mean that, and we can double check again like we did, it would mean that u66 is the last term that's less than or equal to 400. So we can check u66 is a plus n minus 1 d, which is equal to 5 plus 65 times 6, that's 395. Okay, so what this would mean is that the last term here is 395. The one before that would have been 395 minus 6, 389. And then the first one outside of the boundary is 395 plus 6, which is 401. So that would be 395. We say that's term 66. This would be term 67. So I hope this makes sense, that the last term that's less than or equal to 400 is the term 395, which is in position 66. And now all we want to do is to find the sum of the numbers within this interval. And to do that, we can say the sum of the first 66 terms. So that will give us everything here. But we need to subtract the sum of the first 25 terms. Because if I remove the first 25 terms, I just remain with term 26 all the way up to term 66. Okay. And so to do that, we can use our nth term formula, which is half n times 2a plus n minus 1d. So for S66, that's going to be 66 over 2 times 2a being 5 plus n minus 1. So 66 minus 1 times d minus 25 over 2 times 2 times a being 5 plus n minus 1, 25 minus 1 multiplied by 6. Let's simplify this part first. So that's 66 over 2 times 2 times 5 plus 65 times 6, 13,200 minus, that's 25 over 2 times 2 times 5 plus 25 minus 1 times 6, that's 1925. We subtract that from 13,200, we get 11,275. I hope that makes sense. It is some question, this one. I will give it that. It takes a lot of brain power to actually understand what's going on here. But if you understood that, then all done. Because doesn't make too much sense, to be fair. Number 6. The diagram shows a circle C of radius r, where x is greater than 0 and y is greater than 0 for all points on C. The least distance between any point on C and the x-axis is 8 units, and the least distance between any point on C and the y-axis is 5 units. All right, so we're given this diagram where we've got our y-axis and our x-axis, and we've got this circle here, and it's got a radius r. Okay, and we're told that this is circle C. So we're told that the least distance between any point on C and the x-axis, so this distance here, is 8, and then the least distance between any point on C and the y-axis is this distance here, that's 5. Okay, and part A goes on to ask, state the coordinates of the center of the circle C in terms of r. All right, so we need the coordinates of the center, so we'll start with the x coordinate. So the x coordinate would be the distance 5 plus this distance there, which is r. So 5 plus r. And then the y coordinate would be this distance, 8, and then that distance there, which is r. So 8 plus r. That will be the center of your circle. Part B says, given that the distance between the origin and the center of the circle is 15 units, find the value of r. So the distance between the origin and the center of the circle, that there is 15. Okay. So that allows us to draw a triangle, which I'll draw on the side. So this part is the center of the circle, this part is your origin, and then we know that this distance here, that's this distance here, which is 5 plus r, right? And then the vertical distance of your triangle is that part, which is 8 plus r, right? Because this is just taking us to the center of the circle. And then we have been given that the distance between your origin and the center of the circle is 15. Forgive me if you can hear the dog barking in the background. But not even a dog is going to stop us from doing math. This is a right angle triangle, so we can use Pythagoras, right? A squared plus b squared is equal to c squared. So in our case, we can say that this is part B. A squared, that's 5 plus 3 squared, plus 8 plus 3 squared. 5 plus 3 squared is your a squared. B squared is 8 plus r squared. Did I say 5 plus 3 squared? 5 plus r squared. This is equal to c squared, which is 15 squared. And now, yeah, it looks like the only way is to expand. I don't see any shortcuts. So let's expand our brackets. Square the 5, 25. 2 times 5 times r, that's 10r. Square the r, that's r squared. Square the 8, that's 8 squared, which is 64. 2 times 8 times r, that's 16r. Square the r, that's r squared. This is equal to 15 squared, which is 225. And now we are going to reduce this to a 3-term quadratic. So we've got r squared plus r squared, which is 2r squared. And then we've got 10r plus 16r, which is 26r. And then we've got 25 plus 64. And we can bring this 225 that side and subtract it. So 25 plus 64 minus 225. That gives us minus 136. And this is all equal to 0. And clearly, this is all divisible by 2. So I can divide through by 2 and get r squared plus 13r. Then we've got 136 divided by 2, so minus 68 is equal to 0. Is this divisible by 13? I don't see a way to factorize this by side. Can we factors of 68? 68. It's divisible by 4. It's divisible by 4. Okay, so we can factorize this because it's divisible by 4. Alternatively, you can just use the quadratic formula, but I hate using the quadratic formula, so I'll almost always try to factorize. If you divide 68 by 4, you get 17. So I know I should have 4 and 17. Those are factors of 68, right? We want this to add up to 13. So I have to do plus 17 minus 4, which gives me 13. So either R is 4 or R is minus 17. And in the context of our question, R represents the radius. The radius of a circle is going to be a positive measurement, so you can conclude that therefore R must be 4. Part C says the point on the circle furthest from the origin is denoted by P. Find the gradient of the tangent to the circle at P. So we're told that the point on the circle furthest from the origin is denoted by P. So that will be this point here, because that's the point that's furthest from the origin, but still on our circle. And they're interested in the gradient of the tangent at this point. So that's point P. To get the gradient of the tangent at the point P, I can note that my line, my tangent, is going to be perpendicular to this green line, right? Because the green line is going from the origin to the center. And then from the center, we're going through to point P. So it's still the same line. So these lines are going to be perpendicular because the radius is always perpendicular to our tangent. So if I can get the gradient of the green line, I know that m1 times m2 is equal to -1, where m1 is gradient of the green line, m2 is gradient of my tangent, since these two are perpendicular to each other. And I can get the gradient of my green line because now I know the coordinates of my center. R is 4, so my center should have coordinates 5 plus 4 and 8 plus R. 8 plus 4. So my center is going to have the coordinates 9 and 8 plus 4 is 12. So I'm looking at a line of this form. It's starting from the origin 0, 0 and it ends at 9, 12. Right? So the gradient of that is just change in y over change in x, which really is just 12 minus 0 over 9 minus 0, which is equal to 4 over 3. So that will be the gradient of this green line there. And we can tell that this has to be perpendicular to the tangent at P. So we can say that 4 over 3 times the gradient of our tangent is equal to -1. So the gradient of our tangent is -1 over 4/3. So the gradient of our tangent is -3/4. And so we can conclude that part C, gradient of our tangent is -3/4. Number 7. Show that 3 tan squared theta plus 5 sine squared theta is identical to 8 sine squared theta minus 5 sine to the 4th theta over 1 minus sine squared theta. We have two options here. We could go from right to left, or we could go from left to right. I think we'll go from left to right because it does seem a little bit quicker. So We know the identity tan theta is identical to sine theta over cos theta. If I square both sides, I have that tan squared theta is identical to sine squared theta over cos squared theta, right? Because I'm just distributing the power 2. I can use that on the left-hand side, on the tan squared theta here. So that's sine squared theta over cos squared theta plus 5 sine squared theta. And the reason I changed the tan squared theta is I can tell that my right-hand side has absolutely no tan squared theta. So it's in my best interest to get rid of tan from the jump. And the next idea, or eventually we want to get everything in terms of sine. So I will probably get rid of or change the cos squared theta. But what I want to do first is notice that here I've got two separate terms, but on the right hand side, everything is just one single term. So I want to put everything over a common denominator, right? So I can just put everything here over cos squared theta. And so here I've got 3 sine squared theta. And then this becomes 5 sine squared theta multiplied by the denominator. 5 sine squared theta cos squared theta. And now finally, because I can tell that everything on the right hand side is in terms of sine, I'm going to rewrite cos squared theta in terms of sine using the identity cos squared theta is identical to 1 minus sine squared theta. And so this becomes 3 sine squared theta plus 5 sine squared theta. And we're rewriting cos squared theta as 1 minus sine squared theta. And this is all over 1 minus sine squared theta. And if we simplify this, we've got 3 sine squared theta multiply 5 sine squared theta by 1, that's plus 5 sine squared theta, multiply 5 sine squared theta by minus sine squared theta, that's minus 5 sine to the 4 theta. And this is all over 1 minus sine squared theta. And so this is, if we add like terms, we've got 3 sine squared theta plus 5 sine squared theta, 8 sine squared theta minus 5 sine to the 4 theta. And this is all over 1 minus sine squared theta, therefore proving the identity 3 tan squared theta plus 5 sine squared theta is indeed identical or equivalent to 8 sine squared theta minus 5 sine to the 4 theta over 1 minus sine squared theta. So that's part A. Part B says, hence solve the equation 3 tan squared theta plus 5 sine squared theta equals 9. For theta is between 0 and 270 degrees. So make sure your calculator is in degrees. 3 tan squared theta plus 5 sine squared theta is equal to 9 for theta is between 0 degrees and 270 degrees. Those are odd boundaries. They rarely give 270 as a boundary. It's usually like 180 or 360. But oh well. So in part A, the reason they say hence is because they want you to use what you deduced in part A, which is that the 3 tan squared theta plus 5 sine squared theta that we have here can be written as this. And I know at first glance it might seem like this is going backwards because the right hand side looks more complex, but it's actually simpler in the sense that everything is in terms of sine on the right hand side. So that will be much simpler for us to simplify and eventually get a quadratic, and it looks like sine squared theta, which we can easily solve. Oh, easily in quotation marks, of course. And so 3 tan squared theta plus 5 sine squared theta, we know that we can rewrite that as 8 sine squared theta minus 5 sine to the 4 theta. And this is all over 1 minus sine squared theta. And this is equal to 9. We've just replaced the left-hand side. And now I want to get rid of the denominator. So I'll multiply both sides by 1 minus sine squared theta. So 8 sine squared theta minus 5 sine to the 4 theta is equal to 9 times 1 minus sine squared theta. And so that's 8 sine squared theta minus 5 sine to the 4 theta is equal to 9 times 1, that's 9. 9 times negative sine squared theta, that's negative 9 sine squared theta. Put everything on one side. I will move everything on the left to the right because I want the coefficient on sine to the 4 theta to be positive. So if I move the negative 5 sine to the 4 theta, it becomes positive 5 sine to the 4 theta. And then I've got my negative 9 sine squared theta already. If I move this 8 sine squared theta, it becomes negative 8 sine squared theta. And then I've got the 9 already there, and this is all equal to 0. So 5 sine to the 4 theta minus 9. These are like terms here. Minus 9 minus 8, so minus 17 sine squared theta. Those are odd numbers. No pun intended. Me laughing at my own joke. Anyways, this, hopefully you can see that this is a hidden quadratic. And I can rewrite sine to the 4 theta as 5 sine squared theta squared. Because if I do 2 times 2, I get back my 4. Right, minus 17 sine squared theta plus 9 is equal to 0. So I can create a substitution and say let u equal sine squared theta. And so that becomes 5. Wherever there's a sine squared theta, replace with u. So I've got 5u squared minus 17u plus 9 is 0. And this I will gladly punch into the quadratic formula because I don't think we can factorize that by side. Minus b plus minus the square root of b squared minus 4ac, and this is all over 2 times a being 5, so u is equal to, that's 17. We'll start with the negative 1, so minus root 17 squared minus 4 by 5 by 9, and this is all over 2 by 5, which is 17 minus root 109 over 10, and the positive one should just be 17 plus root 109 over 10. But remember, we used a substitution that said let u equal sine squared theta. So if u is sine squared theta, it means that sine squared theta is equal to 17 minus root 109 over 10. And we also have sine squared theta is equal to 17 minus root 109 over 10. Sine squared theta is 17 minus root 109 over 10. Take the square root on both sides, so sine theta is equal to plus or minus the square root of 17 minus root 109 over 10. Remember to put your plus or minus anytime you take a square root. So theta, in fact, I'll separate this as 2 equations. So I've got sine theta is minus root 17 minus root 109 over 10. And then I'll have the positive 1 sine theta is equal to positive root 17 minus root 109 over 10. So here we have that theta is equal to arcsine of negative the square root of 17 minus root 109 over 10. And so theta is equal to, that's arcsine of negative the square root of 17 minus root 109 over 10. And I'm in radians. Make sure you're in degrees. This gives us negative 54.0881. That's our principal value. And we can use this principal value to see if we've got other solutions within the interval. The way I like this, there's multiple ways you can find solutions within the interval. You can use your CAS diagram. You can use the following formula, PV minus 1 to the n plus 180n, which you can just try out at n is equal to 1, at n is equal to 2, until you get out of the range that they've given you. But the way that I prefer to do this nowadays is to just sketch out my sine graph. In this case, since we're solving an equation in sine, we can sketch out a sine graph. If you were dealing with an equation in cos, you'd sketch out a cos graph, right? So my sine graph would look like this. I need a bit of the negative part of it as well. So we are in degrees. So I know that peak there is 90, that there's 180, that there's 270, and that there's 360. If we go backwards, that there would be negative 90, that there is negative 180. And the solution that I've found is at negative 54.0881. So that would be approximately negative 54, right? Would be maybe somewhere here. Maybe I've even moved too close, but it doesn't matter. What matters is that it's before negative 90 or in front of negative 90, depending on which way you want to look at it. So it will be somewhere here, right? And what you're going to do is to draw a line that goes through like that. And what we want to use is symmetry. Okay? So I know that I'm going to have a solution at this point here, which is clearly less than 270. So we want that solution. This solution is now greater than 270, so I'm not interested in that solution. So I can tell because of symmetry, this region here would be the equivalent of this region here. So the distance here is 54.08. So the distance here should be 54.08. I hope that makes sense. It's slightly not so symmetrical because this should have maybe shifted across like that. But, you know, my diagram is not very accurate. But yeah, so hopefully you can see that my next solution is going to come from just saying theta is 180 plus the 54.08 by symmetry. Theta is equal to 180 plus 54.08, which is 234.08. Alternatively, you could have used the formula that I mentioned, which is PV times negative 1 to the n plus 180n. When n is 1, I'm sure you get the same value. So you would say your principal value, that's the value you get from your calculator. which is the negative 54.0881. Multiply that by negative 1 to the power of n, or n is 1, plus 180 times 1, which is the same as 180 plus 54.088. So it will give you 234.08. So either draw the diagram, use the formula, or use the CAS diagram. And then, so this 234, that's the only solution within the interval from that equation there. Let's evaluate this equation here. And don't forget equations, because we still have this equation up here that we haven't dealt with, right? What happened here? This should be a plus, okay, not a negative sign. All right, so we still have to come back to that equation after we're done with this equation here. So with this one here, we're going to say theta is arcsine of root 17 minus root 109 over 10. Theta is equal to, that's arcsine of root 17 minus root 109 over 10. And this is 54.0881. Shocker. And same procedure. We want to sketch out our curve. This time I only need the positive part. So this would be 90, this would be 180, this would be 270, this would be 360. So I've got my point, my principal value being theta is 54.08. So 54.08 would be somewhere here. If I draw a straight line going through here, I can tell that my solution, my other solution will be at this point here. By symmetry, this part here should be the same as this part here. So it must mean that this distance here is 54.08. 54.08. So if I just subtract 54.08 from 180, I'll get my value there. So I can say that my theta is going to be 180 minus 54.08, which is 180 minus that, 125.9. And that's the only solution, the only other solution, because this 54 does fit within our interval and this 125.9 does fit within our interval. So now we just need to check our sine squared theta is equal to 17 plus root 109 over 10. So let's do that on the side, yeah. Sine squared theta is 17 plus root 109 over 10. Take the square root on both sides. Sine theta is equal to the square root of 17 plus root 109 over 10. Don't forget plus or minus. And a good thing to always check, especially when you've got values like this, is root 17 plus root 109 over 10. Is that greater than 1? Because this value here, we're saying that sine theta is equal to plus or minus 1.6565, right? Remember that your sine graph ranges from 1 to negative 1. So if you've got a value, we've got 1.65. Let's say 1.65 is somewhere here. It's never going to intersect our sine graph. So we're never going to have any solutions when we try to equate 1.65 to sine, right? So that's always a good thing to check. If your value is bigger than 1 or it's less than negative 1, then it's never going to give you any solutions. So from here, we know that we're going to get no solutions. Or if you want, you can punch it into your calculator and you get an error, and you know that, okay, there are no solutions here. So let's collect all the solutions that we've gotten, starting with the smallest. Smallest one was the 54.0881. So I'll run that off to 54.1 degrees. The next one was the 125.9 degrees. And the next one is the 234. Let's round that to one decimal place. That's 234.1 degrees. And that there would be our final answer.
By the way, if you like the way that I break down questions, there's also a good chance you like the way that I tutor. I run a one-on-one tutoring program where I help E and D students transform their grades into A's and A stars so that they can get in their dream university. So if you want that to be you, click the first link in the description down below and I'll make it happen.
Number 8. A geometric progression is such that its second term is negative 120 and its sum to infinity is equal to 160. So that's the stem of the question. And then part A says find the common ratio. All right. So recall your formulas for geometric progression. The nth term formula from the MF19 is AR to the n minus 1, and your sum to infinity formula is A over 1 minus R. So in this case, we have that our second term, U2, is negative 120. So that means A times R to the power of 2 minus 1, which is just 1, is equal to negative 120, right? So AR is negative 120. And then sum to infinity, that's A over 1 minus R, and that's equal to 160. And so we just have two equations in terms of A and R that we can solve simultaneously. So let's make A the subject of the formula here. So multiply both sides by 1 minus R. And you've got A is 160 times 1 minus R. So A is equal to 160 minus 160R. And then we can substitute into this equation here. So that becomes A, which is 160 minus 160R, multiplied by our R, and that's equal to negative 120. And so 160 times R, that's 160R. Negative 160R times R, that's negative 160R squared, is equal to negative 120. I'll move everything to the right hand side because I want the coefficient on R squared to be positive. So that becomes positive 160R squared. This becomes negative 160R. And our negative 120 is equal to 0. We can divide through by, what is it? Is it 40? 16 over 4 would give me 4. Yeah, we can divide through by 40, and we'd have 4R squared minus 4R, then 120 over 40, 12 over 4, that's 3, is equal to 0. Can we factorize this? We could do 2R, 0, and then factors of 3. So I'm thinking negative 6 plus 2R. If you multiply 2R by negative 3, you get negative 6R. If you multiply 1 by 2R, you get plus 2R, which gives us negative 4R, which is that. So that's fine. You can use the quadratic formula. Here, this is a bit tricky to factorize, so you're probably better off using the quadratic formula. But if you can, it is much faster, so do that. So here we get that either 2R plus 1 is 0 or 2R minus 3 is 0. So either R is a half, or this should be negative 1 half. So either R is a half for r is 3/2. So here we can conclude that our common ratio should be r is -1/2. If you go to the MF19, you see that next to the formula for sum to infinity, there will be something like this, right? The modulus of r is less than 1. That just means that r should be between -1 and 1. So for your sum to infinity, or for a sum to infinity to be possible, your common ratio has to be between -1 and 1. Otherwise, you don't get a sum to infinity if it's not within those bounds. So 3/2, that's 1.5. That's clearly outside of that range. So we can conclude that it has to be the -1/2. Right? So that's part A. B. The first 9 terms of the progression are now removed. Find the sum to infinity of the remaining terms of the progression. Okay. So remember, in the stem, this was part of the stem of the question. So we can still use this information in part B, right? And from using this information, we found that r is -1/2. But now we've been told that the first 9 terms of our progression are removed. And so this means that what would have been the 10th term in the previous progression is now our first term here. So if in our previous progression, we had u2 was -120. So we know what our common ratio is. Can we go backwards? Our first term, AR is equal to that. So A has to be -120 over -1/2. So our first term would have been 240. And if you multiply 240 by your -1/2, you get your -120. Multiplied by -1/2, you get the next term. -120 by -1/2, that gives us a 60. You multiply that by -1/2, that gives us a -30. You keep going, 15. You keep going, -7.5, and so on. This is the progression, the geometric progression from part A, right? It would start with A being 240, your second term is -120, the third, the fourth, the fifth, the sixth. But now we've been given that they've removed the first 9 terms of the progression. So it means that for this new progression that we have, our first term becomes the 10th term because we've removed the 9 terms. So U10, that's AR to the power 9. So from part A, well, we now know that A would have been 240. And the way you'd get that is to say that you know your second term from the nth term formula is AR, and that's equal to -120. We know what R is. A times -1/2 is -120. Divide both sides by -1/2, and you get that A has to be 240. So 240 times our R, which is -1/2, raised to the power 9. So 240 times -1/2, and this is to the power 9. That gives us -15/32. So for our new progression, we now have that our A is -15/32. The common ratio still remains the same because remember, the common ratio is just what you're multiplying to get to the next term. So they haven't said anything about changing that. They've cut out the first 9 terms. The way the progression is formed is still the same. You're just multiplying by -1/2. So our common ratio is still -1/2. So the sum to infinity is going to be a, which is negative 15 over 32, divided by 1 minus our common ratio. And so the sum to infinity here becomes negative 15 over 32 over 1 plus 1 over 2. That gives us negative 5 over 16. Or if you like, you can give it as a decimal, negative 0.3125. That would be our sum to infinity. Number 9. A curve is such that d squared y dx squared is 6 over x to the 4 minus 5 over x to the 3. It is given that it's got a stationary point at half 9. So that's a stationary point. In my head, I'm already processing. I've seen a stationary point. dy dx has to be 0, right? And then in part A, they say that use the expression for d squared y dx squared to determine whether the stationary point is a maximum or a minimum point. Okay. So here we're just evaluating our second derivative at the stationary point. So we're evaluating the second derivative at x is equal to 1 over 2. This is just fancy notation to say that I'm evaluating my second derivative when x is 1 over 2. Okay, so substitute x with 1 over 2, 6 over 1 over 2 to the 4 minus 5 over 1 over 2 to the 3. This is equal to, that's 6 over 1 over 2 to the 4 minus 5 over 1 over 2 to the 3. That's 56. So since our second derivative is equal to 56, which is greater than 0, the point, what's the point again? Half 9 is a, that's going to be a minimum point. If your second derivative is positive, you've got a minimum point. If it's negative, you've got a maximum point. And part B says find the equation of the curve. 7 marks. That's a hell of a question. Okay. So we're starting with the second derivative. Just write d squared dx squared. We're starting with the second derivative, d squared y dx squared. If you integrate this, you get the first derivative dy dx. And if you integrate this, you get the equation of the curve. Y is equal to whatever it's equal to, right? So we are going to have to integrate twice. If you integrate second derivative, you get first derivative. If you integrate first derivative, you get the equation of your curve. So that's why that's worth 7 marks, because you're going to have to integrate twice. What is our second derivative? We've got d squared y dx squared, and this is equal to 6. I'll bring the x to the 4 up to the numerator. It becomes x to the negative 4 minus 5. I'll bring the x to the 3 up to the numerator. It becomes x to the negative 3. And so we want to integrate this. We're going to integrate both sides with respect to x. If you integrate the second derivative with respect to x, you get dy dx. If you integrate 6x to the minus 4, you're going to add 1 to the power. So negative 4 plus 1, that's negative 3. Divide by the new power, minus 5x. Add 1 to negative 3, so negative 3 plus 1, that's negative 2. Divide. And remember, always add a constant of integration. So dy dx is equal to 6 over negative 3, that's negative 2, x to the negative 3, negative 5 over negative 2, that's positive 5 over 2, x to the negative 2, plus our constant of integration. We're going to need to integrate for a second time. But before we integrate, we actually need to find what our constant here is, right? And so that's where that whole stationary point comes into effect. So we know that when x is 1 over 2 and y is 9, dy dx is 0. We can use that bit of information to help us find our constant. So we know that our dy dx is 0 when x is equal to 1 over 2. So 1 over 2 to the negative 3 plus 5 over 2, 1 over 2 to the negative 2. Again, because it's a stationary point, dy dx has to be 0. So you've got 0 is equal to, that's negative 2 multiplied by 1 over 2 to the power of negative 3 plus 5 over 2 times 1 over 2 to the power of negative 2. So negative 6 plus c, so c has to be 6. And so we have that our dy dx is equal to, that's negative 2x to the negative 3 plus 5 over 2 x to the negative 2 plus 6. All right. And now that we've evaluated the constant, we can now integrate both sides so that we can get our equation of the curve. So again, you're integrating both sides with respect to x. So I'd made a mistake on integrating this. So I noticed that after I'd finished recording. So I'm just going to correct that. So if you integrate dy dx with respect to x, you get y. And then if you integrate negative 2x to the negative 3, that's negative 2x, add 1 to negative 3, that's negative 2, divide by negative 2. And then you've got plus, you've got 5 divided by 2, x, add 1 here, negative 2 plus 1, that's negative 1, divide by that negative 1, plus 6, that becomes x, and of course plus a constant, excuse me, of integration. So we've got y is equal to negative 2 over negative 2, that's 1, so that's just x to the negative 2. And then here we've got 5 over 2 times negative 1, so that's negative 5 over 2. And that's x to the negative 1 plus our 6x plus our constant of integration. And remember, we have been told about the stationary point with coordinates half 9. So we know that when x, y is equal to 9, and we can use that information to evaluate our constant of integration. So 9 is equal to 1 over 2 x, or 1 over 2 to the negative 2 minus 5 over 2, 1 over 2 to the negative 1 plus 6 times 1 over 2 plus k. And we've got 9 on this side, and then we've got, that's 1 over 2 to the negative 2 minus 5 over 2 times half to the negative 1 plus 6 times half, which gives us 2 plus k. So our constant here should be 9 minus 2, which is 7. And so therefore, the equation of the curve becomes y is x to the negative 2 minus 5 over 2, x to the negative 1 plus 6x plus 7. And that's the 7 marker. The idea behind it is not too difficult. If you understand the purpose of integration, if you start with the second derivative, you integrate, you get to the first derivative. You integrate the first derivative, you get to the equation of the curve. But it's more so just when you integrate, the second derivative, you're going to get a constant, right? When you're at your first derivative stage. Here, it's what to do with that constant. That's the tricky part. But remember that at a stationary point, dy dx is 0. So we know that we had our stationary point, which had coordinates half, 9. So we know that when x is half, dy dx is 0. And then use that, get your c, integrate again, and then use the same point, but now using x and y coordinates to get your other constant of integration. And then, yeah, you get your equation of the curve. Not too difficult, just be careful to not make any silly mistakes like I had made. Let's go on to question number 10. So the diagram shows the curve with equation y is equal to 4 times 3x plus 4 to the half minus 2x minus 6. So the curve is going to be the red one, right? Y is equal to 4 times 3x plus 4 to the half minus 2x minus 6. For values of x such that x is between 0 and 7. So 0 is there, so this has to be 7. The tangent to the curve at the point P with coordinate 7, 0. So P has coordinate 7, 0 meets the y-axis at the point Q. So a tangent to the curve at point P meets the y-axis at point Q. Okay. Region A is bounded by the curve and the two axes, our y-axis and our x-axis. Region B is bounded by the curve, the line segment PQ, and the y-axis. Okay. Part A says find the region, the area of region A. All right, so region A, that's the red area. That's just area under the curve. There's really nothing to it. So that means we just need to integrate our curve from 0 to 7. So that's 4, put big square brackets, 4 times 3x plus 4 to the half minus 2x minus 6 dx. We'll start with this part here. So start by integrating the outer function, which is the one with the power half. So add 1 to the power half. So we've got 4, 3x plus 4. Add 1 to half, you get 3 over 2. Divide by the new power, 3 over 2. And now differentiate the inner function, which is the 3x plus 4. If you differentiate 3x plus 4, you get a 3. So multiply by that 3 in the denominator. And now integrate negative 2x. So that's negative 2x, add 1 to the power, divide by the new power. Then negative 6, that just becomes x. This is from 0 to 7. So let's simplify. Here we've got 4 divided by 3 over 2 times 3. So that's 4 over 9 over 2, which is 8 over 9. Okay. 8 over 9. And that's multiplying 3x plus 4 to the power of 3 over 2 minus 2 over 2. That's 1. So just x squared minus 6x. And this is from 0 to 7. So let's substitute in our limits. We'll start with the upper limit. So 8 over 9 times 3 times 7 plus 4 to the power of 3 over 2 minus 7 squared minus 6 times 7. And then the lower limit as well. So that's 8 over 9 times 3 times 0 plus 4 to the power of 3 over 2 minus 0 squared minus 6 times 0. So that's just O minus 0 there. All right, so let's evaluate. We'll start with the upper limit. That's 8 over 9 times 3 times 7 plus 4, and this is all to the power of 3 over 2 minus 7 squared minus 6 times 7. We get 181 over 9. That's subtracting the lower limit here. That's 8 over 9 times 0 plus 4. 8 over 9 times 0 plus 4 raised to the power of 3 over 2 minus 0. So 64 over 9. And so area of region A has to be, that's 181 minus 64 over 9. That's 13. That will be our answer for part A. Then we've got part B. Part B is find the area of region B. So to get region B, it's going to be the area under your blue line PQ. So it will be the whole triangle, OQ, OP, PQ. So the whole triangle, and then subtract the red area. That will give you the blue area. And because it's a triangle, there's two ways we can do this. We can either integrate, or we can just do it geometrically by using half base times height. But first, we actually need to know what the equation of this line is. The blue line segment PQ, we need to know what the equation of that is. Otherwise, we don't really know what the coordinates of Q are, and we can't do much without that information. So let's find the equation of the line segment PQ. To do that, remember that in the question, they told us that P is a tangent to the curve. So P is a tangent to the red curve. So we can find the gradient of the line PQ because that's going to be the gradient of the tangent to the curve at point P. So we can differentiate our curve and then substitute x with 7 to get the gradient of the tangent to the curve at the point P. So let's do that. So we have that y is equal to 4 times 3x plus 4 to the half minus 2x minus 6. So dy dx is equal to, so differentiate this. This is a function inside of a function. So we're going to use the chain rule. So what you're going to do is first differentiate the outer function, which is the one with the power half. So you're going to bring down the power half, and we're multiplying by 3x plus 4. Subtract 1 from the power, that's negative 1 over 2, and then multiply. Now you're going to differentiate the inner function. So differentiate 3x plus 4, you get 3. Okay. And now differentiate negative 2x, that's negative 2. Differentiate a constant, you get 0. So dy dx is equal to, let's simplify this. So 4 times half times 3, that's 6 times 3x plus 4 to the negative half minus our 2. So this is the gradient function of the curve, and we want the gradient of the curve at a specific point, which is the point P. So we want dy dx at the point P, which has x being 7. So that's going to be 6 times 3 times 7 plus 4 to the negative half minus 2 is equal to. So that's 6 times 3 times 7 plus 4 raised to the power of negative a half minus 2, and that gives us negative 4 over 5. So we know that the gradient of the tangent to the curve at the point P is negative 4 over 5. So if we're using the form y equals mx plus c, we know m is negative 4 over 5 and we're given point P to have coordinates 7, 0, we can just substitute this and find what the y-intercept is. So our y is going to be 0, our m, that's negative 4 over 5, our x is going to be the 7 plus c. So c is going to be, that's 28 over 5. So it means the equation of the tangent to the curve is y is negative 4 over 5 x plus 28 over 5. Okay. So we've got two options. We can either integrate this equation from 0 to 7 to get the area under the line between 0 and 7, or we can just get the area of the triangle. We now know that the y-intercept of our line PQ is 28 over 5, because that's the C from our equation. Y is equal to, with negative 4 over 5x plus 28 over 5, right? This is our y-intercept. We now know that there we've got our x being 0, our x is 0, and our y is 28 over 5, because that's the y-intercept. So we can just get the area of our triangle, because the height of our triangle, that's going to be a 28 over 5. The base of your triangle, that's the 7. So we can just do half base times height to get our triangle, which would be half times 7 times 28 over 5. So triangle, it was OPQ is equal to half base times height, base being 7, height being 28 over 5, which gives us 1 over 2 times 7 times 28 over 5. That's 98 over 5. So that's the area of the triangle OPQ. But remember, we have to remove the red area so that we end up with just the blue area. So the red area we evaluated in part A to be 13. And so we can say that area B is going to be 98 over 5 minus 13. And so therefore area B has to be equal to 33 over 5. And that's our final answer. Number 11. Functions f and g are defined for all real values of x by f of x is equal to 4x squared minus c, and g of x is equal to 2x plus k, where c and k are constants, positive constants. Okay, c and k are positive constants. And then it is given that g inverse of 3k plus 1 is equal to c. All right, that's useful information. Part A says, show that gf of x is equal to 8x squared minus k minus 1, 4 marks. Okay, so if we want gf of x, we're going to go into g of x and substitute its x with f of x. All right. So wherever there's an x in g of x, we're going to replace that with our f of x. So this becomes 2 brackets. Our x becomes f of x, which is 4x squared minus c. And that is plus k. Right? So we have that gf of x is equal to, we can expand this, that's 2 times 4x squared, that's 8x squared, 2 times negative c, that's negative 2c, plus k. All right. So what they want is, should probably write part A here. what they want is gf of x is equal to 8x squared minus k minus 1. So notice that the main difference is that their expression for gf does not have a c. So we need to find a way to get rid of our c. And we can do that using this bit of information we've been given here. Right? We've been told that g inverse of 3k plus 1 is equal to c. So we need to find a way to rewrite our c in terms of k. And remember that if you've got a function g of x, or rather, so that it matches what we have. Remember, if you've got an inverse function, g inverse of x, and I apply the original function, the original function and the inverse will just cancel out and you just get x. So if you apply the original function to its inverse, it cancels out. Just the same with something like root x. If I apply the power to, the root and the power to cancel out because they're inverses, right? And I just end up with x. So here we have that g inverse of 3k plus 1 is equal to c. I can apply g to both sides so that I can cancel out g and g inverse on the left. And I've got 3k plus 1 is equal to g of c. And this helps because I can evaluate g of c using my g of x function. G of c is just going to be replacing the x with c. So I have that 3k plus 1 is equal to 2c plus k. 2c plus k. And now this gives me an equation in terms of k and c, which therefore allows me to then find an expression for c in terms of k. So I can say that 2c is equal to 3k minus k, which is 2k, plus 1. And I can say that c is equal to, divide both sides by 2, so that's going to be k plus 1 over 2. And so we can come back to our expression here for gf of x and substitute c with k plus 1 over 2. So we can say that gf of x is equal to 8x squared minus 2c, but we now know that c is k plus 1 over 2 plus k. And so we have that gf of x is equal to 8x squared minus 2 times k, so minus 2k, minus 2 times half, minus 1, plus the k. And if we simplify this, we have that gf of x is equal to 8x squared. We've got minus 2k plus k, which is minus k, and then the minus 1. So we have shown that gf of x is 8x squared minus k minus 1. Part B looks like a transformation. The curve with the equation y is equal to 8x squared minus k minus 1, right? Y is equal to 8x squared minus k minus 1, which is our gf of x, is transformed to the curve with equation y is equal to h of x by the following sequence of transformations. So we've got a translation of 2, 3, and we've got stretch in the y direction by scale factor k. And then we've got reflection in the x-axis. And they're saying find an expression for h of x. So converting that to y equals h of x through the sequence of transformations. Okay. So let's just do a quick refresh of transformations. If you're starting with a function of the form y equals f of x, and you apply a translation in the x-axis by a units. So translation x-axis by a units, positive a units by the way, this becomes y is equal to f of x minus a. All right, so that's translation in the x. And then if you're starting with y equals f of x and you do a stretch in the x by scale factor 1 over a, this becomes y is equal to f of a x. Remember, it does the inverse in the x-axis. If you had moved by positive a units, it becomes negative in there. If your scale factor was 1 over a, it becomes a, which is just the reciprocal. And then we can do the same for our y-axis. So translation in the y, rather again, you're starting with the y-axis. You're starting with you're starting with y equals f of x. And then if you translate this in the y-axis by a unit, this one is exactly as you would expect it to be. F of x, you're just adding a to f of x. And then we've got y equals f of x. If you stretch this in the y-axis by scale factor a, then you get y equals a f of x. All right, and then you've got your translation, your reflections as well. So reflection, again, you're starting with y equals f of x. So y is equal to f of x. If you reflect in x-axis, this becomes, it makes your y values negative. So y equals negative f of x. And then if you reflect in the y-axis, it makes your x values negative. So it will be y is equal to f of negative x. So all of these are all the transformations that you'd have to know. We've got the translation in the x, we've got the stretch in the x, we've got the translation in the y, we've got the stretch in the y, and we've got the two reflections. Okay, so that's the form that they take when you're moving from the description to the function form. Description, function form. Okay, so let's see if we can apply that to this question. So we are given that our starting function, right, is y is equal to 8x squared minus k minus 1. So that we're in keeping with the examples we've done here, I'll just call this starting function our f of x, right? So if we say apply, if we define f of x as 8x squared minus k minus 1, and we want to move f of x to h of x, our first transformation here is a translation of 2, 3. So we're moving in the x-axis by 2 units and in the y-axis by 3 units. So remember, x-axis by 2 units becomes x minus 2. And then y-axis by a units becomes f of x plus a. So plus 3. All right. And then we've got a stretch in the y-axis by scale factor k. So stretch in the y-axis, it's just going to multiply your whole function, right? So it's going to multiply your whole function. And our scale factor is k. And then we're given that we've got a reflection in the x-axis, a reflection in the x-axis makes our y values negative, so it multiplies your whole function and makes it negative. So it's going to multiply the whole thing and make it negative. So this here would be an expression for h of x in terms of f of x. But now we need to actually substitute, right? So it becomes h of x is equal to negative k times f of x minus 2. So wherever there's an x, you're going to replace it with x minus 2. So that becomes 8 times x minus 2, and this is squared, minus k minus 1, minus k minus 1, and then we've got our plus 3. Okay. I hope that makes sense. I was just following the instructions that we laid out here on the side for how our transformations work, and then just applying them in the order that they've given us here. And of course, you can simplify h of x. That's, we could do, let's start with the bracket first. I'll keep the negative k outside. And then we could do 3 minus 1, which is 2. So we've got plus 2 minus k. And maybe we can leave it like this. We could multiply through by k. Yeah, that will probably be better. Negative k times 8, negative 8k times x minus 2, and that's squared. Then negative k times 2, so minus 2k, minus k times minus k, plus k squared. The reason that I multiplied through by negative k is because this looks more, or this is the completed square form of h of x, which is usually more useful to have. So, and I think it could actually be useful in our part C. Part C says the range of h is given by h of x is less than or equal to 15. Find the values of c and k. Okay. No pun intended. Right. So remember when I said h of x was in the completed square form? That is actually very useful to us. Squared minus 2k plus k squared. All right. So if we sketch this out, I know that my h of x is going to look something like this because I've got a negative 8. So my x squared is going to be negative. Remember that k was said to be a positive constant in the stem of the question. So I know that I'm going to be multiplying my x squared by a negative number. So I know I'm going to have a set face parabola, right? And I know that this point here, if I have a y-axis, I know that this point here is going to be 15 because I've been told that h of x is less than or equal to 15, which means that the maximum point on h of x is going to be at 15. But notice that the maximum point is a turning point. And from my completed square form of h of x, I know that my coordinates of the turning point are going to be, when is this bracket equal to 0? So x minus 2 is 0, x is 2. And I know that my y value is going to come from that part. Because remember, if you've got your completed square form of the form a x plus b squared plus c, your turning point is going to be minus b and c. So the x comes from whatever makes this bracket 0, and then the y value comes from whatever is adding outside the bracket. And so in this case, our c would be the negative 2k plus k squared. So that's the y value, negative 2k plus k squared. And if this is the y value at the turning point, then it must be equal to 15, right? So negative 2k plus k squared is equal to 15. And lo and behold, we have a quadratic. Minus 15 is equal to 0. I think we can factorize this. So we can do 5 and 3 minus 5 plus 3. And so either k is minus 3 or k is 5. And remember, in the stem of the question, we were told that k and c are positive constants, so k has to be 5. And then to find c, remember there was a point where we found an expression for c in terms of k. So we can use that expression. We know that c is k plus a half. So c is k plus a half. So c is 5.5 or 11 over 2. So we can conclude k is 5, c is 11 over 2, and that will be our final answer. And that's the paper as well. I hope you found this breakdown useful, and if you did, I would really, really appreciate it if you would just smash the like button, subscribe, and share this with your friends. Thank you for watching. And so it would be AB is equal to B squared plus C squared plus 2BC, so 2 times 10 times 10 cosine of, oh man, oh, it's minus 2BC. You see, this is the reason why I should never use the cosine. I can never for the life of me remember this formula correctly.